Welcome back to another chemistry lecture. Today we are going to start talking about concentrations and solutions, and I'm going to go through a pretty big chunk of your PowerPoint. And believe it or not, I'm going to skip some things. So the first thing you'll notice is the very beginning of your PowerPoint is a review of some things we did earlier in the year. Talking about mixtures, heterogeneous mixtures and homogeneous mixtures, talking about colloids, talking about solutions, how are there other names for homogeneous mixtures, and then different techniques for separating mixtures, decanting, centrifuging, chromatography, distillation. So take a few minutes on your own, make sure you review that part, but I don't think we really need to review it here. So we're going to start a little further on in your notes in PowerPoint with the idea of concentration. Now this is not a new word, this is a word you guys have heard many times throughout your life. And what concentration is really talking about is our ratio of solute to solvent. Okay? What we're really focusing on here is we are focusing on solutions, homogeneous mixtures, evenly mixed one thing throughout the other. And because this is a homogeneous solution, what we see is that concentration is something that is consistent from top to bottom in a solution. Remember, the name solution means evenly mixed. It's homogeneous. So when we are calculating concentration, there's really three methods that we can use. Okay? Method number one is we can look at something called parts per million, or ppm. Truthfully, we don't do much of this at this level of chemistry. You'll see it a little bit with gases. You'll see it some in advanced chemistry, but not much. To calculate parts per million, what you do is you take your grams of solute, that's what you're putting in, divided by 1,000,000 grams of solvent. So it's exactly what it sounds like, parts per million. How many grams of solute can go in 1,000,000 grams of your solvent? And your solvent is what you're putting things into. So truth is, we don't use parts per million very much. So let's look at the second one. The second one is something called molality. Now, college level chemistry, you're going to use this one a lot more. We are not. But molality is abbreviated with a lowercase m. Sorry, I shouldn't have put that equal sign there. And to calculate molality, you are going to take your moles of solute, all right, the thing you're putting in, and that's going to be per kilogram of solvent. All right, so sort of like parts per million, except we're focusing on moles, and then we're looking at the kilograms of solvent. But again, we're not really using that one at this level of chemistry. What we are going to use, what you need to know, big time, because it is all over your SOL, is molarity. Okay, molarity is abbreviated with a capital M. You've actually seen this several times already this semester and not known it. And molarity is calculated by your moles of solute divided by your liters of solution. And we're going to come back to that in a minute. That's different than solvent. So most of what we're going to focus on in this lecture is going to be molarity because that's the one we really care about. So let's focus on it. First of all, let's look at the term molarity. Whenever you read this, you're going to just see it abbreviated with a capital M. You'll see a 3M solution. When you read that, usually we say it is a 3 molar solution or it's 3 moles per liter. That's generally what we look at. So a real big key here is that if it has the same molarity, it has the same concentration. Okay, that's really what it is. And that means no matter the amount. Molarity is a measure of concentration. Okay, how potent is it? So if you have two little thingies here, okay, this one has like 20 liters, okay, of 1 molar HCl. And then this one has got like little drops down at the bottom. This one has 1 milliliter of 1 molar hydrochloric acid. And I ask you, okay, which one of these is the most concentrated? Okay, or which one of these is the strongest, the most potent acid, A or B? Your gut wants you to go to that. Or some people are like, well, there's less of this, so it's this one. Guess what? You're both wrong. The answer is neither. They are actually the same. Okay, this 1 molar means these are exactly the same concentration There's just a greater amount of it here. It's like having a pitcher of iced tea and you put a drop in one person's glass and you fill up somebody else's. It's the same tea in both glasses, it's just different amounts. Another thing you got to remember with molarity is how to prepare a solution. Now, in our chemistry class, we don't do much of this, okay? Most of the time when you guys come into lab, in fact, all the time when you come into lab, I've already got everything made for you. It's just because we don't have enough time to do it ourselves. But if you know molarity, you can prepare a solution. The catch is you got to remember what molarity is. Molarity is moles of solute, solute per liter of total solution. Okay, what that means is I can't take 1 mole of my solute and then put it in 1 liter of water to get a 1 molar solution. It doesn't work. It's the same idea of if I've got a glass, okay, in fact I'm going to make it over here on the right. If I want this glass filled to this line with ice water, all right, that's my goal. I cannot take this much water, okay, and this much ice and combine them together and have everything go up to this perfect little line. That's not going to work, okay? Pretend these 3 cups are the same size. You guys know the ice takes up space, so you'll end up getting a much higher total volume. The same is true when you're looking at molarity. So you can't just look at total solution as the water that's involved. You have to literally look at it as a total. So what we do to make a liter of total solution, let's say we wanted that 1 molar solution, is we would take a mole of our solute, okay, and we would dissolve it in some water. All right, so I could have a little Erlenmeyer flask here. Whoa, that thing is ugly. And I'd put my powder down in there, okay, and let's say the green line is going to be the total I want. What I'll do is I'll take my mole of solute and I'll put it down in there. Then I will actually add some water, okay, and I'll stir this thing up and I'll shake it up and I'll make sure everything is dissolved, and then I just would keep adding water until I got up to the line. I don't actually even necessarily have to measure the water in this case, okay, because I know I want a liter of total solution. That's what I care about. Okay, so that's something to think about as you go farther on. All right, so let's get back to calculating molarity. You're gonna love this, trust me. Here's a practice problem, okay? It says 0.3 moles of potassium bromide are dissolved in 0.4 liters of solution, okay? And that says solution, not of solvent, so that's helpful. What is the molarity? Molarity is all over your SOL. So what you've got to know is the formula. Molarity is moles per liter. Now I'm going to look at my problem. Okay, it's asking me to find the molarity. Okay, I've got 0.3 moles. All right, I got 0.4 liters of total solution. I plug it in the calculator. That is a 0.75 molar solution of potassium bromide. Ta-da! That's molarity. Okay, seriously, that's molarity. The hardest molarity gets, okay, is, let's say I ask you, what is the molarity, start that way again, of, this time we'll do potassium chloride, that has a volume of 400 mils and has 85 grams of potassium chloride. Okay, so let's say that problem is given. It asks me what the molarity is. So I'm like, dude, I got this. Molarity is moles per liter. But when I go to get my numbers, there's a problem. I don't see moles. While we're at it, I don't see liters. So that tells me I have to do what? I have to convert. That's as hard as this is going to get. Okay, you've got to know that to change milliliters to liters, you take that decimal back 3 places. So you've got to know that this is going to be 0.4 down here because I moved that decimal. You also have to be able to say, okay, 85 grams of KCl. Well, I know that I can take 85 grams of KCl and I can convert it to moles by using the molar mass off the periodic table. Chlorine is 35.5, potassium, is 39, so when I add those up, I get 74.5. Sorry, it's a little squenched in there. So when I do my calculations, then I end up getting that this is 1.14 moles. Okay, go back to my calculator again. 1.14 divided by 0.4 gives me a molarity, of 2.8. Okay, so the hardest this can get is making you deal with moles and liters. I got a couple other samples in the PowerPoint you can look at, but again, all of them are looking at the same thing. All right, so to add a piece on the molarity, I want to talk about one more thing in this video, and then we'll move on. Okay, I want to talk about dilutions. Most of you guys know what it means to dilute something, all right? You're adding water, you're thinning it out. So really what a dilution is it's adding a solvent, okay, to end up decreasing the concentration. You can have really dark Kool-Aid, then you add water, you get a little bit less, little bit less, little bit less. The big thing to remember about dilutions is it does not change the solute at all. When you add water, you're not taking Kool-Aid powder out of your glass. You're simply adding more water. So what would happen is if I had a whole bunch of glasses lined up here, okay, and I had some, now I have limited colors here, so humor me, but if I had really dark Kool-Aid here, all right, and then I added some water to it, you know what would happen? It would be a little bit lighter here, and there'd be a little more of it. And then I add more water, and it's a little bit lighter, and there's more because I've added water. Then I add a little bit more water, and it's a little bit lighter, and there's more of it. So molarity and volume have an inverse relationship. Okay, the lower the volume, the more concentrated it is, the darker it is. The higher the volume, the more dilute it's become. So your formula to calculate dilutions, another formula to learn, is M1V1, starting molarity, starting volume, equals M2V2, ending molarity, ending volume. So these problems, pretty simple, okay? One that's in your notes, you have 2 liters of a 0.88 molar solution, okay? That's a point, I swear. And it's diluted, there's your key word, you know what formula you're using, to 3.8 liters. And I want to know what's the new molarity. So, plug and chug time. M1V1, okay? M is 0.88. Your starting volume is 2. Equal to, the new molarity is what I'm looking for, times the new volume, which is 3.8. Very similar to gas laws, just plug and chug. Okay, so hopefully that gives you a good idea of molarity and dilutions. We'll be back next time with solubility.